Start recording.
All right. Hello, welcome to the demo. So first we'll start off with deploying our system. So I'll start with opening Neo4j. In the meantime, I'll start up the code for this. All right. So check our Neo4j, it's active. Another thing we have to do is turn on the cluster deployment. So what we have to do is run mongoscript.batch as administrator. Right. So this is the first replica set. I gave it a little bit of delay just so it can prepare itself. I'll click again to start it up. All right, now both replicas are deployed. And to confirm that both are working, I'll open MongoDB Compass. And we'll attempt to connect to one of the clusters, so the 27018, and connect it just fine. Now, typically, you wouldn't want to connection directly to the replica in most cases, but we just did that for example to show it's working. All right, now that we have that open, we can now start the application. All right, so first what we'll do, we can see that the user's not logged in, so nothing's going on there. So first we'll log in as one of the users. Okay. And then we'll make our tweet. Okay, and then once we have that posted, we can go to recommendations. And we can see now that we see a lot of recommendations from the user Neo4j. And we can also see tweets where either it was Neo4j or with the graph database. Since it was prioritized with mentions, typically tweets from Neo4j will go first. So then we'll go to Neo4j browser. And we'll go find the user. All right, so we see the user and we can see the tweet that was posted. Graphs are great. And you can see the sentiment was positive, and it was mentioned to Neo4j, saying that everything worked as intended. All right. Next, we'll log in as another user. Then we'll post another tweet. This time only with the hashtag. All right, and then you see now in the past we've posted some other ones previously. So these are from like previous instances, but showing that with the twin4j hashtag. And if we go to Neo4j browser, and we do the same query match for the user, we can see obviously there's a bunch of duplicates from previous times, but we can see I love twin4j and the sentiment was positive. Okay, so now that we show the functionality of the application, we'll go towards the code. We'll start out with the HTML pages. So it's pretty straightforward. Login is just enter username, enter your password. Both are required. You have to log in. Recommended is just outputting the data at, into the page with a for loop. Standard is just the navigation menu and its standard template for all the other ones to follow. And then tweet is just a straightforward one where you're just posting the tweet and submitting it. For our Flask route handler, we have three main Flask routes. We have tweet, login, and recommend. Tweet is basically it just checks to see if a user's logged in. It won't let you post a tweet if you don't. Either way, even if you try to tweet without a profile, it won't let you. And if it's not in the session at all, it'll just notify you right away. And if you do post and the user is there, it'll insert the tweet into the database into Neo4j. It'll upload the tweet towards MongoDB for patch processing and then apply the sentiment analysis. The login is basically just checks the user and password that was entered in, checks to see if it exists in the database, and logs the user in if it's true. Otherwise, it'll give them an error message. And then recommend is basically once the user posts a tweet, the user will see the recommendations they got based off of the mentions and hashtags that they posted. On the load file, basically this is for initialization of the database. This is a one-time run file. It's not currently running. All it does is basically query the database and extract all the data from Neo4j and place it into MongoDB. We see here our schema is author Neo4j, and we just put the tweet text. And now you can see multiple authors, same author, but different tweet. And the other one is the user authentication database, where we just have all the passwords as the same, because it's not realistic, but it's what we have. And we just have each username. And you can see here we populate the database with insert commands, just with a key. Moving on, we'll go to mongo.py. These are just the functions to verify the login as well as store the tweets for batch processing. So this just checks to see if the account exists in MongoDB. Otherwise, it'll just reject it. And upload tweet is it just adds the tweet to the database collection. Pretty straightforward. Our natural language processing query, unfortunately, we couldn't get Kafka streams to work, so we simply applied the sentiment analysis during the insertion step in app.py. We can see like right here, sentiment analysis. And it just takes the polarity using text blob and based off the polarity, categorizes it as negative, positive, or neutral, and just finds the tweet and sets the statement to the sentiment. All right, and Ali will go towards these tweets or these queries.
And this is the query Python file where we are actually running the queries in Neo4j with the Python vault driver. So first we just got the authentication. So first you just got to use your username and your password tailored to your Neo4j server. And then the loops within this driver is basically just parsing the mentioned users and the hashtags from the tweet that we're going to insert. And then when we go down into the Cypher query, it's just matching the user based on the screen name. And then it's creating a node that user tweets, which also creates that relationship of the user actually tweeting that post. So when we go down, and then also for these loops right here, it's just merging the user with the screen name. And it's actually like parsing that mentioned user from the inserted tweet that I mentioned earlier. And same for hashtag. It's just merging the hashtag with the actual hashtag name in the Neo4j database. And it's parsing that hashtag from the tweet and creating like a relationship of the post that tags that hashtag, same with the mentioned as well, or the mentioned user as well. And then you can run the session or run the query with the Python bot driver. And then same with recommendation tweet or recommend tweet function. It's the same as insertion tweet. So obviously it's just parsing the hashtags and the mentions. And then when we go down into the recommendation query, it's just matching that hashtag based on, or just matching the hashtag that's tagged with that tweet and that is posted from that user. And then it's just recommending the tweet based on the mentioned users and the hashtags. And then on the bottom, it's just formatting the recommendations based on the user and the tweet text. And on the bottom, just disregard the bottom. That's just examples of us inserting tweets just to test our Neo4j database.
Okay, so then we'll go towards the configuration files. So there are two primary ones, mungoscript.bat and mungod.cfg. So mungoscript was the file that we ran earlier. If we look at the command prompt, we can see that the result was based off this status. We checked to see the current status of the MongoDB replica. So we see that it's at ID1 is set as primary, and the two nodes ID0 and ID2 are set as the secondary. So right now this is a single leader based replication model where ID1 is receiving all the writes, and ID0 and ID2 are copying all data from ID1. This way it gives high availability and reliability. The only catch is that it has lower write throughput compared to read throughput, which should be fine primarily because for batch processing, we can afford to have a lower write throughput. Going into the bat file, it basically just adds these IDs to the configuration, and then these start the replica sets in these pans right here, or these pages right here. And then going to the configuration file, it's pretty straightforward. We just uncomment replication and set the replica name to RS0. And that's pretty much the gist of this project. We create a MongoDB replica cluster for batch processing and storage. We decided replica based because there's no point in having, again, arbitrary partition when you can simply go with replication, which, while it's less efficient space-wise, it's higher reliability and has higher write throughput, which is ideal for a batch-based model. Moving on, we'll go to the schema visualization.
We can just do that real quick.
All right.
So first, we just got to run the query into Neo4j, call call db schema.visualization. Yeah. And this is just a data model of how, I guess, the Twitter works within Neo4j. So there's 5 nodes, and there are a bunch of relationships. So first, we just got the tweet, which can retweet itself, or the user can retweet the tweet. And we have me, which is basically the user Neo4j, and then it can follow another user, and then a tweet can contain a link. A tweet can use a source, and a tweet can tag the hashtag which we parsed with our insertion queries and recommendation queries, and then the user can reply to a tweet, and the user can post a tweet, and a tweet can mention like the mentioned users that we parsed from the insertion queries as well. And then, yeah, users can follow each other as well. So this is just a data model of how the tweets, or how Twitter works within Neo4j. So thank you for stopping by and listening to our demonstration.